Okay, this is a center of mass problem also. So I have a person who's in a boat, right? And the boat is touching the pier. And after a while, this person is going to walk to the back of the boat, and the boat is going to move away some distance, right? So it's going to move here. And the question is, right, it started here and it moved some distance here, right? So this is before and this is after. And the question is, how heavy is the boat? So it's a center of mass problem. So how far the center of mass moves is going to equal, it's going to equal the change in all this stuff. So it's the mass of the man times where the man is, plus the mass of the boat times where the boat is, right? It's the change in all this, divided by mass of the man plus mass of the boat. It's kind of like this is basically our center of gravity, center of mass formula, right? Same thing. It's the mass, each one times its component divided by the sum of all the masses. Okay? So let's look at what this is. So this is the mass of the man times the change in position of the man plus mass of the boat times change in position of the boat over mass of the man plus mass of the boat. This has to equal 0 because the center of mass of this system doesn't move. As the person's here, right? As the person walks forward, the person's going to go forward, the boat is going to go backwards, so that the center of mass of the whole system stays put. Right? So it's like if you're on a floating raft. If you're standing here on a raft and you walk this way, the raft is going to move this way, but the center of mass is always going to stay where it is. Right? That's what this is saying. Okay. So now I can just take this equation and kind of simplify it a little bit. Right? So this equation basically says mass of the man times delta x man plus mass of the boat delta x boat equals 0. Right? So that means the mass of the boat equals mass of the man times delta x of man over negative delta x of the boat, right? If I do some algebra, and that is what I can use to solve. Okay, so I know the mass of the boat. No, I don't. I'm solving for the mass of the boat. Oh yeah, look, I know the mass of the man though, 70.8. Okay, so what are these numbers? The delta x of the man. That's how far the man went, right? So how far the man went is however long the boat is. Right? Or, however long the boat is. So, delta x of the man is the length of boat. The length of the boat minus the distance it went from the pier. Right? So whatever this length, that length minus this length, that's the length the man went. Right? If I subtract 4.1 minus 1.75, those are my numbers. Subtract those two, that's delta x for the man. And then delta x for the boat, that's just this number. That's distance to the pier. Right? So another way to write this, delta x for the man is the length of the boat minus delta x for the boat. And delta x to the boat is just whatever that distance was. So in mine, my problem would be 4.1 minus 1.75 goes here. And the distance the boat went was 1.75. That's delta x for the boat. And if I subtract these two, that's delta x for the man. Right? So again, just a center of mass problem. Same thing. You multiply each mass by how far it went, and then divide it by the sum of the masses. But in this case, we had to set it equal to 0 because they're moving, right? And we're just solving that.